Hello everyone, this topic is continuity. Today I will start continuity. Hello everyone, I'm Nur Azjani. Today I will teach you about the idea of limit. So the limit notation is like this. Limit x approach to a fx equal to L. L means the value of y. Okay? This is the example of the graph. We can see that when we find the limit of 2, we can get the answer is 4. To find that, we can consider both sides, which is the right side and the left side and the right side. So to write the equation, we can say that x approach to negative, which means the right side, while for the right side is positive. This is left side and the right side. So what means the limit? Limit is the value of near to 2, which means the value approach to 2, near towards 2. Okay? To find the limits, we can use a few methods, which is substitution, factorization, conjugate, highest value, and using a table. The easiest way is by using a table. So this is an example to find a limit. Limit x approach to 3, a function. So why we cannot use substitution? Because if we substitute 3, we will get 0 over 0. So it is intermediate value. So we can use another method is factorization to find the limit, which is 2 over 3.
Now we learn to how evaluate value of limit by looking the graph. At the right side, we had to complete the Tarzan puzzle by finding value limit based on the graph on the left side or the correct answer for the certain information. You can make your own Tarzan puzzle to try. So this is a function graph of fx. For limit x approach to negative 4 from left, we found that the value of y is 4. That means the limit for this equation is 4. While limit x approach to negative 4 from the right is negative 2. Next, look the Tarzan puzzle. We must find what limit that will not exist or TNE. We know that if there is no continuous graph at the point, and means the limit does not exist. So, at the x equal to negative 4, there's no continuous graph, so the limit is DNE. Continue with which function of limit will be equal to 0. By look at y equal to 0, this function is the answer, which x approach to negative 6 from the right. Infinite limit is always DNE because it have a large value that we don't know. So this graph looks like the value of limit will be infinity. When x approach to 4 from the right, the graph going upwards. That means the value limit equal to positive infinity. Limits defined when there exists value of y. Limit exists when the both sides of limit from left and right will be equal. And that's all.
Next session, I will explain about complete limit. This is a basic theorem in complete limit. First is a limit as limit k s approaching to a. K is the constant. So we can, if s approaching to a, we just take a constant value is k. Next, limit x approaching to a, x. We will substitute x is a into f, so we can get is a. Limit 1 over s, s approaching to 0 for the left, we can get negative infinity. Then, limit 1 over s, s approaches to 0 on the right, we can get positive limit. Okay, to make it more understandable, I will give you some example. Okay, this is limit x of x to the power of 2 minus 3x plus 2 over x minus 2 x opposite to 2. First step we should do is substitute 2 in this function, so we can get 0 over 0. This is a indeterminate form. Indeterminate form. So we can get a limit. So what we must do? We must use another method, which is there is 3 methods. First, factorize, then multiply by a conjugate, then is the divide by highest power. Okay, for this station, we can factorize this. Okay, so we get limit x equals to 2, x minus 2, and x minus 1 over x minus 2. Okay, we can cut this, so we can get x minus 1. So we substitute this in s. So 2 minus 1 can get 1. That is the answer. Next we go to piecewise different function. Okay. For this, first step we must do is we must do the interval. The interval to find a correct function. Okay, ni 1 because we get 1. Okay, and okay. X less than 1, so the function is fx equal to 4 minus x over 2, and x greater than 1 get h x equal to 2 plus x to the power of 2. So this is a h x. Okay. This is x approaching to 1 from the left, is x approaching to 1 from the left side. Okay. If we want to find limit x approaching to 1, we must find the first side of limit. Okay, first I do a left for the limit for the left. Okay, limit 4 minus x to the power of 2, x approaching to 1 on the left. So we just substitute 1 in x. 4 minus 1 over 2, we can get 3. Okay, next we do from the right. Okay, from the right, limit 2 plus x power of 2, x approaching 1 from the right. Okay, we substitute this 2 plus 1 power of 2, and we can get 3. Okay, so we can see that limit from the left and right is the same. So we can consider that the limit is exists. So therefore, limit h x from the left in limit h x from the right is equal. So we can get x limit x is equal to 1 h x is equal to 3. So that is the answer. So that's all for me. Thank you.
So, Assalamualaikum warahmatullahi wabarakatuh. For the next topic is limit at infinity. So what is actually the limit of infinity is describe the behavior of function as the independent variable which is an increase or decrease. Okay, increase shown as a positive infinity and decrease is about negative infinity without bounds. So this is the example. How do we write the limit at infinity? So limit when x approaches to a positive infinity of fx is equal to L, and the limit x approaches a negative infinity of fx equal to L. Or we can write this by using this. Okay, so the limit x when approaches to positive infinity is equal to limit x approaches to positive infinity, c over to x power of r equal to 0, and the limit x when approaches to negative infinity, c over x power of r is equal to 0. So c here must be any real number, and r here is only a positive rational number. So now we try to do this example. Okay, this one is a limit s when approaches to positive infinity. 5x minus 4 over 2x plus 3. Okay, first one, we need to choose the higher degree of this numerator and denominator. So for numerator, the higher degree is 1. So we choose 1 here, 5x. And for the denominator, 2x is the higher degree for denominator. So the easy way, we just bold this one and we write here 5x 2x. Okay, second one, we need to divide with the higher degree of denominator. So the higher degree of denominator is 1. So we divide this term with x. The answer equal to 5 over 2. Okay, sorry. X just positive infinity 5 over 2. So we don't have any x, so do not need to substitute infinity in this term. So the answer will be 5 over 2. So that's all from me. Thank you.
Next, we continue with topic continuity. Continuity defined as function f continuous by following condition. First, fc is defined. Fc is defined meaning there are value at that point. At that point, there are value. Next, limit fx x approaching c is exists, which is limit fx x approaching c left equal to limit fx x approaching to c right. Next, limit fx x approaching c is equal to the fc, which is value limit fx approaching x approaching c equal to value of fc. This is an example, which is if we can see fc, we can get the value of fc, which is which is 3. So FC is defined because there are value at that point. Next, limit fx x approaching to c. So this we need to calculate the limit fx x approaching to c to the left and limit fx x approaching to the c to the right. First, limit fx x approaching to the c left equal to the left. We can get the value is 3. If we can see by the graph, the limit is approaching to 3, which is 3. Limit fx x approaching to c to the right, you can see it approaching to the 3. So this meaning, limit fx x to the c x approach to c is exists because limit fx x approaching to c to the left equal to the limit fx x approaching to the c to the right. Next, limit fx x approaching to c equal to fc, which is we know that limit x approaching to c is 3. fx is 3 and limit fc 3. So because of this is equal, that's mean and this condition and this graph follow the condition. That means this graph, we can say this function is continuous. Okay, next, continuity, polynomial and rational function. Polynomial, continuous everywhere. While rational function, continuous when denominator is does not equal to 0. When denominator non-zero. So this is an example. We can see if denominator, this is denominator, we equal to the 0. If we get the value which is this function is not continuous, but if we can get the value, that means the function is continuous. So we can get x4 and x2 equal to 0. So we get x equal to 4 and x equal to 2. This yield to the discontinuity. Yield discontinuity. Okay, last but not least, there are 3 types of discontinuity, which is jump discontinuity, infinite discontinuity, and removal discontinuity.